Good day, our viewers at home. You're welcome to another sections of Apex Easy Learning. Today we'll be looking at organic chemistry. Organic chemistry. This is the organic chemistry. First, what is organic chemistry? Organic chemistry is the chemistry of carbon and its compound, with the exceptions of carbon oxides and carbonate, meaning it involves elements with carbon the main element, hydrogens, oxygens, halogens, nitrogens, and sometimes phosphorus and sulfur may be present. Carbon, being a tetravalent element, has the ability to form a covalent compound. It also has the ability to combine with another carbon atom to form chain or ring compound. This ability is what we refer to as catenation. Catenation, meaning catenation is the ability of carbon to combine with another carbon atom to form chain or ring compound. Carbon also have the ability to form multiple bonds. That is, it can form double bond or even triple bond. That is multiple bonds. So that is the properties of carbon that make carbon to switch in this organic chemistry. Hydrocarbon is another aspect of organic chemistry that we must know. Hydrocarbons are compounds which contains carbon and hydrogen only. Carbon and hydrogen only. Majorly, they are petroleum, meaning crude oil. Crude oil are the main source of the hydrocarbon. We have types of hydrocarbon. We have aliphatic hydrocarbon, which are straight or branch chain hydrocarbon. Example of that are alkanes, alkenes, and alkynes. These ones are aliphatic hydrocarbon. Then we have aromatic hydrocarbon. They are cyclic hydrocarbon with benzene-like structure. Benzene-like structure, meaning we can have a structure like this. This is ring hydrocarbon. This is benzene. This is benzene. So any hydrocarbon that have this like structure are aromatic hydrocarbon. Also, we have saturated compounds. They are compounds with single covalent bond. They are compounds with single covalent bond. Example of that is alkanes. Alkanes are saturated hydrocarbon. Then we have unsaturated hydrocarbon. They are compounds with multiple bonds, that is, double bonds or triple bonds. We have alkenes and alkynes as unsaturated hydrocarbon. Another thing we must look at is homologous series. Homologous series is a family of organic compounds in which each successive member differ in their molecular formula by CH2 group, meaning the difference in the molecular formula of the series is CH2, meaning one carbon and two hydrogen. That is homologous series. Apart from the homologous series, we have the properties of the homologous series that we'll look at before we go forward. One, as we said, each successive member differ by CH2 in its molecular formula, meaning the member are differ, meaning by one carbon and two hydrogen. Then we have another property that they have the same general molecular formula. Alkane, which is a homologous series, have a molecular formula CnH2n plus 2, while alkenes, which is another homologous series, has a general molecular formula CnH2n. Alkanol is also one. We have CnH2n plus 1 OH. This is alkanol. So homologous series, when you have them, they must have general molecular formula before you can say they are homologous series. Another property is that the members of the same family have similar chemical properties. Members of the same family have similar chemical properties, and also members of the same series have similar method of preparation. Meaning, if you look at the members of alkane, if you look at the first member, the method of preparation is similar to that of the second member. Another properties is the melting point, the boiling point, and the density of each series increases as the number of carbon atom or the number of chain increases. As the chain increases, the melting point, boiling point density also increases. Another thing is the solubility. The solubility decreases as the number of carbon atom increases. These are the properties of homologous series. In our next class, we'll start with alkane. Thanks for watching. Welcome back. We are now on alkane. Last class we finished with homologous series. We are now starting with alkane. Alkanes are saturated hydrocarbon with carbon-to-carbon single covalent bond, meaning between carbon and carbon we have single covalent bond, carbon-to-carbon single covalent bond. So that is alkane. That is alkane. So they are homolog with general molecular formula CnH2n plus 2. So don't forget that we said homologous series, they have general molecular formula. So alkane, we said, is one of the example of homologous series. So the general molecular formula is CnH2n plus 2. So if you look at the members of alkane, we can easily find out the members of alkane using that formula CnH2n plus 2, CnH2n plus 2. So if our N is 1, we'll be having CH2 times 1, 2, plus 2, that is 4. That is CH4. This is the one we call methane. The second one, if N is 2, we'll be having C2, H2 times 2, that is 4 plus 2, that is 6. That is C2H6. If N is 3, we'll be having C times 3, that is C3, H2 times 3, 6 plus 2, that is 8. Now, don't forget that we said if a group is homologous series, they differ by 1 carbon and 2 hydrogens. So if you look at the first member and the second member, you see that the difference between the carbon number is 1 and the hydrogen number is 2. So meaning the next member, we just add 1 carbon and 2 hydrogen, will give us the next member. So the next member here now, if you are to find it, it will just simply be C4H10. That is butane. The next member will be C5H12. That is pentane. Next one will be C6H14. That is hexane. C7H16. that is decane, octane, C8H18, that is octane, and C9H20, that is nonane, then C10H22, that is decane. So from this table you can see from carbon 1 to carbon 20, the carbon 11, C11H24, just follow that, either the formula or just be adding one carbon. Look at it, if you apply the formula, you are going to get it, or you just add one carbon, two hydrogen, you get all up till number 20, icosane. So when you look at it, undecane, dodecane, tridecane, tetradecane, pentadecane, hexadecane, heptadecane, octadecane, nonadecane, icosane. So this is the first 20 members of alkanes in that order. Now let's look at the property of alkane. First of all, we are going to look at the physical properties of alkane. First one, the first four members of alkane are gases. Why from that's carbon 7 up to carbon 17 are liquid. Then anything above carbon 18 are semi-liquid and solid at room temperature. Then alkanes are generally insoluble in water, but they are soluble in polar solvent. Alkane as well, they have boiling point increases as the carbon chain increases. Then they are less dense than water. That is the physical properties of alkane. But in questions, sometimes they do ask about a particular member, the simplest member of the family. The simplest member of alkane family is methane. So we are going to look at the physical property of methane. First of all, methane is a colorless and odorless gas. It is slightly soluble in water. It is less dense than air. It is neutral to litmus paper. That is property of methane. Then we are looking at the chemical properties of alkanes. Alkanes bonds in oxygen to produce water and carbon 4 oxide. Generally, alkane, when they bond in air, they give us carbon 4 oxide and water. For instance, now when you look at methane, when methane bonds in air, it burns with a pale non-luminous flame and give us steam. It gives us carbon 4 oxide and a lot of heat. Now when you look at it, we have CH4 plus oxygen and it gives us water, which is steam. This water here is steam. Then carbon 4 oxide, which is a gas. So this is combustion of alkane. Another chemical property, which is a reactions, is a substitution. Substitution reaction is a direct displacement or replacement of an atom by another atom or group. In this case, the atom that always displaces another here must be of high electronegative element, which can easily displace the lower electronegative one. For instance, elements like chlorine, bromine, which are of high electronegative value compared to hydrogen, can easily displace hydrogen and to give us haloalkanes. Now, when you look at a very simple reactions of halogenation here, or chlorinations of methane here, methane reacts with chlorine in the presence of ultraviolet light to yield a mixture of products. That is, the product that will give us will be haloalkanes. Haloalkanes or alkyl halides too. It's still alkyl halides. Then if you look at it, this reaction is we said is going to give us a mixture of products, meaning that there we can have different products being produced. If you look at it, the first one here, the methane react with chlorine, it gives us methyl chloride or chloromethane. Let's look at how we have it. So the first reaction here, you see CH4 methane reacting with chlorine to give us chloromethane. First of all, the chlorine will split with the help of ultraviolet light, and methane also will separate and chlorine will be added to it, and you will have chloromethane. But these reactions will continue to occur until the whole of the hydrogen is replaced with chlorine. If you look at the second stage, one chlorine also displaces another hydrogen and we have dichloromethane. Then the third one, chlorine also displaces another hydrogen, we have trichloromethane and tetrachloromethane, like that. In every of the process, you see that hydrogen chloride gas is produced in that process. So that is halogenations of methane. That is halogenations of methane. So let's go to uses of alkanes. Uses of alkanes. They are majorly used as fuel, like carbon 1 to carbon 4 and natural gas. Like if you look at it very well, your carbon 3 and carbon 4 are the major gas, the major component of the gas we use as cooking gas at home. Then carbon 5 to carbon 8 are gasoline, that is petrol and the rest. Then we have carbon 9 to carbon 16. There we can talk about kerosene, diesel, and some oil like that we use for fuel as well. We have any carbon 7 upward. There we can have lubricating oil and some solid like wax, coal tar, and the rest. So these are the things we used as industrial fuel and also domestic fuel as well. Then we have methane is also used in preparations of some substance like element hydrogen gas, Then we also use it in productions of chloroform. You can also consult your textbooks to know more about the uses of those things. So this is where we are going to stop for today. You can send your questions as usual to our page, our Twitter handles, our Instagrams and Facebook page. All your questions will be treated there. Thanks for watching.